So today we are gonna discuss about another question, which is find an expression find an expression for time period for time period of spring that depends that depends on mass m and force per unit length k. So if you watched one of my previous videos, we also found the time period, but we used different formulas. We said that the time period of a simple pendulum depends upon its length and acceleration due to gravity. So let's do it for a time period of a spring, which depends on mass and force per unit length, which means F by L, which we are going to represent by K. So let us derive the time period of spring. So here, according to question, or from the question, we know that the time period depends upon mass. Let's say it's to the power a. This will be number 1, equation 1, and t also depends on force per unit length. This will be 2, where a and b are constant to be determined or found. A constant to be found or to be determined. So now, combining equation 1 and 2, we will get, it's not actually equation, but I'm gonna write equation anyways. So let's remove this. I thought about writing it, then I was like, nah, not gonna write it. So now we have t is directly proportional to m to the power a and k to the power b, and to remove the proportionality sign we will have to add a proportionality constant. And since I would generally write k, but since k is already used, it will make it more complicated. Just think about it. If I wrote t is equal to k m to the power a, k to the power b, you will get confused on if this k and this k are the same. So that's why I'm gonna use another constant, which is also popular, which is c. C is also represents constants in many cases. So this will be our equation 3, and where c is dimensionless proportionality constant. So I'm just gonna write proportionality constant. So now here the dimension of t, which is time period, is time t. The dimension of k is, the formula is force upon length. Force is mlt minus 2. Dividing it by length gives us mt minus 2. So it will be mt minus 2. And finally the dimension of m, which is mass, will be m. And c is dimensionless quantity. So now, since we have the dimension of the terms right here, we can write. So now we can write it as the dimension of t must be equal to the dimension of c m to the power a, k to the power b. So when writing it, we can write it as m0 l0 t, which will be equal to, c does not have a dimension, so we can write it as the dimension of m is m to the power a, the dimension of k is mt minus 2 to the power b. So to write it out, we will have m0 l0 t. So let's see right over here, is there any m? Yep, there are two m's, 1 raised to the power of a and 1 raised to the power of b. So that will give us m a plus b. Do we have any L? We don't have any L, which gives us L to the power 0, which is actually cool because you can see that it must be L to the power 0, and here also it is L to the power 0. And finally we can do t. So there is 1t, which will be minus 2b. So now you can see right over here we can check off m and t. We don't have to check for L because 0 is equals to 0. We don't need to write such simple things. So now equating powers of same base on both sides we will get a plus b equals to 0 from this m. Checking out m. Now checking out t, we will get minus 2b. We will get minus 2b equals to 1. So this will be our equation 4 and this will be our equation 5. So now from 5 we can say b must be equal to minus 1 by 2. So keeping minus 1 by 2 over here, we will have a is equals to 1 by 2. You can show that you have solved it, or I'm not gonna solve it because it's a very simple algebra. So now we have a and b, so we can write, so then equation 3 becomes t is equals to c m to the power a, which is 1/2, and k to the power b, which is minus 1/2. So the time period actually turns out to be c square root m by k. So t square root m t is equal to c square root m by k, which is, so let's call this equation number 6. So finally we can write, therefore equation 6 is the required expression. So we can't find the value of c by dimensional analysis, and the experimental, that the value of c turns out to be 2 pi. If you want it, I'm going to write it. So here c is actually 2 pi, but this cannot be found by dimensional analysis. So that's it for today's video, and in the next video we are gonna learn about how to convert system of units from one unit to another unit. So from kilogram to second, from kilogram to gram, minutes to second, seconds to hour, etc., etc.